quantifying risk. Risk is defined based on disclosure scenarios. So these are what the research team need to think about and come up with to think in terms of, okay, do we have other data that are out there? What is the context within which we've collected this data that may render our data disclosive? So those scenarios require someone who understands the context, the place where data are being collected, the settings where data are being collected, but also domain experts who are working within that area. And we said that measures are based on, measures for assessing disclosure risk are based on a combination of indirect identifiers. The assumption is that unique combinations of identifiers have higher risk. So we look at the data and see cases where after you bring a couple of indirect identifiers together, you you only find one person with that sort of combination. That's how higher risk is defined. And then we talked about individual risk, global risk, and categorical versus continuous identifiers. So these are the things that the methods use as input for assessing the risk. And that's the first thing you're doing. You are first assessing what's the risk, what is the level of risk, is it at an acceptable level? What's acceptable? You can look at what they consider to be acceptable general guidelines that are put in the literature, but also the research team has to look at this in connection with the laws and within the country where there's data coming from. So quite a lot of context needs to come into what is an acceptable level of risk. So there's no one size fits all. You have assessed the level, you have the level of risk now, you know, okay, this is my level of risk. Then you apply data anonymization or disclosure risk control. There are different methods depending on whether a variable is categorical or continuous. But some of the things that work with categorical variables do not exactly work with continuous variables. So what you're trying to do now is, you have seen what the level of risk is when you assessed, you want to try and reduce it. So some of the methods for doing this for categorical variables is recoding. Let's say age was in 5-year age groups, and you're finding that when you combine sex, age, and occupation, you have a unique combination of someone who is 35 to 40 years old, who is a pilot and living in a certain area, and is male. So you can record those ages into 10-year age bands, so that that combination now has 6 other people. So you can't pinpoint to say, okay, this is so and so anymore, because 6 people are having that same combination. You can also suppress some data if they are leading to disclosure. So change them to missing. So as you can see already, we are getting some information loss because you no longer have age groups specific to 5-year bands anymore. Maybe they're now 10 years, or maybe you've actually removed some data. There was information pertaining to age, but because you think it's now disclosing, or maybe to occupation, you remove that information for that particular, for some individuals. We will talk a little bit about, okay, how do you come up with these decisions? Sometimes variables that are key to an analysis, such as someone's gender or age, you might not want to tamper with those in the first instance, but look at other things that you may want to let go. You can also use aggregation, so bringing together some values, and then you can add some noise, so disturbs the data a little bit, using a well-defined method. It's not just adding some noise in a unsystematic way, but some way of adding some noise to your data so that when someone thinks they found John, they are not 100% sure. And then swapping also, you can swap around some occupations and so on. So all this thing is leading to some information loss, as you can see. And then yeah, I'm not too sure what I was aiming to do. Restricting access, yeah, might need to remove that point unless if I think about why I added it there. Yeah, when you get these slides, it will be sorted out, either removed or a little bit more explanation added there. Or it might be that there was a variable on occupation, maybe restricting access to that particular variable to leave the other ones, perhaps. I'll look at it a little bit more and add clarification there. And then one example, I guess I've picked on this example because it's one that I used in the case study that I'll show you later, is called winsorization. This is when you have a continuous variable and within it, there are some outliers. So with winsorization, you're just targeting those outliers. You get rid of them by changing them. So for example, if there is someone who is 117 years or whose height is significantly higher or lower than others, so they're like an outlier within the data set, you winsorize, so you don't remove them, but you change the value so that it comes together with the other values so that this person is not isolated. So we assessed the risk in the previous slide. Here I'm showing the control of that risk by applying some anonymization. And how we do that for the different kinds of types of variables, between the continuous and the categorical ones. So it's a cycle like this. You assess risk. After assessing, you see whether the risk is still very high. If it is, then apply some disclosure control. When you apply the disclosure control, at the end of the day, assess the risk again. Is it still too high? Apply further control. So, I gave that example of changing from edge bands of 5-year edge. Let's say we had edge in single edges. So you had edge 1, 2, blah, 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 going on it. 1 year, 2 years, 3 years, blah, blah, blah. And then you find that your data is very disclosive like that. You say, okay, let's put 5-year edge groups. Let's say, yeah, I'm just giving an example. And then after that, so you assessed, you saw that individual level, single edge groups, single edges are not great. They are disclosing. You apply risk control by putting 5-year edge groups, for example, right? And then you assess again, you go back to assessment. How is the risk now? It's still high. If you're still working, or if you think edge will be the thing to work on, the variable to work on again, you control again, perhaps by putting into 10-year edge groups. And then you assess again. But you're doing this together with other indirect identifiers, not just the edge. You assess again. If the risk is good now, then you assess the utility. Yeah. So there's that cycle that you're following, but you're not just doing one variable at a time. You might be working with a couple of your indirect identifiers. So continue this until risk is at an acceptable level. I put acceptable in quotes because it means different things in different contexts. So that's the cycle there. And then you assess utility at the end of the day. I have used this picture of snail mail because when I was a little boy, we used to send around a lot of letters that we were writing by hand or maybe typing and then printing and then putting in an envelope and sending. But it's not very frequent now because of email and text and so on. So a lot of the mailing is happening electronically now. So, because you might be wondering why I put that picture there. I think utility of snail mail has gone down. So I thought it's an interesting picture to use. But the big point here is that you want to assess utility of your data after you've applied those techniques for anonymizing the data. You want to see whether the data are still useful for the purpose that you want to share them or to use them. So compare data before and after anonymization. As we said, there's trade-off between anonymizing your data and the utility. The more anonymous the data are, that's good for the individuals who are in the data, because then they won't be identifiable, but then the utility of the data goes down. So you want to strike the balance. You want to strike balance between those two. Compare the indicators. How are they looking? Are they vastly different between before and after? If data loss is too high, other options for sharing need to be considered. So if you are anonymizing with the aim of making your data publicly available, but you find that the data loss is too high, consider other options, maybe restricted access, so that the utility of the data is preserved. Okay. There's a case study that I want us to look at. Let's see, I'm seeing that there are some questions. These are from, please elaborate about synthetic data. It is not clear to me. So maybe let me do that before we go to look at the case study that I have. So synthetic data is when you use some modeling to alter and to mimic an existing data set. So this is usually done by the producers of the data. You have a data set, it's too disclosive. There's that risk that, individuals may be identified, or for other purposes, or for other reasons, you don't want to share the original data. You then look at the structure of the data, and then you mimic that structure. You might mimic the age distributions, the composition of the data, and various other dimensions of the data. But you make your own data. It's like fake data, but it should closely follow the structure or the nature of the actual data set. So some of the uses of this data, it then allows analysts to test out some analysis on that synthetic data without risking, identification of individuals within the original data, because you've made up some fake data out of the original data. Some of the context within, I don't know whether what I'm saying is helpful for you to understand, but some of the context within which this is used is when you want users to test out some analysis that they have in mind before they come to you to request for your data, because sometimes they request without really knowing whether the data they're asking for might have what they are interested in. So it gives them a chance to play around with the data, but it won't be the actual data. It will be the synthetic data. I hope that addresses the question. The other ones are from earlier on. Okay. Okay, I'll move on to look at the case study. This is the last bit that we are going to look at. So we should be finishing relatively soon. There's some work that we did with a cross-sectional survey data on non-communicable diseases. We wanted to make it available for other researchers to use. So we applied these techniques for statistical disclosure control to make sure that those data, the risk of disclosure was reduced. Okay. So the data came from the MAIR, the Malawi Epidemiology and Intervention Research Unit. This is basically a research NGO that Has a board comprising of Ministry of Health in Malawi, the London School for Hygiene and Tropical Medicine, Kamu's University of Health Sciences, and University of Glasgow. And the non-communicable diseases survey data that we anonymized at the 30,575 adults aged 18 years and above. The data collection happened in the rural northern part of Malawi called Karonga over that period of time, and also from the capital city over that period of time. The data that was earmarked for sharing had 77 variables on the burden of diabetes, overweight, obesity, and so on and so forth. We used some software called SDC Micro. This is an R package. I have used it quite a bit, but when I checked just before this session, I saw that it had been removed from the R libraries. I think there's something that needs to be fixed. I will check with the people who developed the package, and then feedback to the organizers of these sessions in terms of what the status is. But you know, I used it over a couple of years. Not only me, but many other research groups have used SDC Micro, including the International Household Survey Network. So this is a big survey network that brings to, among other things, brings together tools for data documentation, data anonymization, and so on. I think it's a very recent change that they've withdrawn it, but I'm positive that it will be back fairly soon. But we can provide that information at a later point. But they've put it in the R archive, so people who are power users of R may probably be able to still access it. I'm sort of an average user of R, so I wasn't too sure how to get it from the archives to use it. But that's the software we used, SDC Micro. If you Google that, you will get a lot of information about that. And in our context, we had key variables posing disclosure risk from scenarios that we identified, sitting down with researchers and others who understood the context where the data were collected from. We saw that someone's sex, their age group, the site, whether, there are those two sites where the data came from, their education, occupation, and marital status were the categorical variables that posed a risk. The numerical variables that we also thought were posing risk were the weight, the height, the waist circumference, the hip circumference, and the middle upper arm circumference. And the information that we thought was sensitive for when someone is identified, for information that we thought was sensitive to be known when someone is identified was whether someone had asthma, BP, high cholesterol, diabetes, and so on, and TB. But it might be things to do with anxiety, depression, or psychosis, or other conditions of interest. Those may be that may be sensitive information. So those are the indirect identifiers and sensitive variables that we identified. And then this list of variables here are those variables that are things that people see. So whether someone smokes or not, whether someone is piped water, what they use for cooking, and so on and so forth. If you apply techniques to do with the suppressing some of the values and so on, you end up with a huge information loss. So there's a different way for handling them that we applied, and I'll give more details. Okay, so we said that we start by assessing the risk of disclosure. One of the methods that we used was to check for the categorical variables the number of observations violating what is called K anonymity. So K anonymity is when you combine the indirect identifiers. So let's say, so in our case, these were our indirect identifiers: the sex, age group, site, marital status, education, and occupation. If you bring those together, if you combine them together, how many people are going to have the same combination? Yeah? How many people are going to have exactly the same combination? You ideally want many people to have the same combination, because then you can't really tell whether the person that you think you have identified is which line, because the combination is the same. So we checked how many people were violating 2 anonymity, which means how many people, when we combined those indirect identifiers, was only just one person with that combination. 3 anonymity means that that 1,700, it means 1,726 people had a combination. That unique combination was having less than 3 people with that unique combination. 5 anonymity, you say these are when you bring those indirect identifiers together, how many people, the unique combination, does it comprise of 5, less than 5 people? And same applies with the 10 anonymity. So this is what we saw, and we considered this to be very high disclosure risk. And then we also did this summary measure called the expected number of re-identifications. So this is a global measure of risk. You look at the data and say, given these categorical variables that are my indirect identifiers, what is the expected number of re-identifications? So we found that it was like 2,538. So these are some of the key results, but we did other assessments as well. And then we applied statistical disclosure control. For the continuous variables, to remove outliers, we applied what is called Winsorization. I'll show a picture that maybe tries to explain that. We did some recoding, some post randomization method. So post randomization method, you take that bunch of variables that I showed earlier, and then you alter them. The software, the code within SDC Micro sort of helps you to do that post randomization, and then local suppression as well. So suppressing some of the values. So this is just to explain the removal of outliers, or that Winsorization I was talking about. So to the left, you are seeing a combination of each of the variables in the diagonal. So I think I need to use that pointer now. Okay, let's get the pointer, the laser pointer. So here, for example, we have a scatter plot of weight against height. This would be a scatter plot of MOAC versus weight. This here is a scatter plot of height versus MOAC, and so on and so forth. Yeah. So, and then this is like vice versa. One was X, the other one was the Y, and then vice versa. So you see there are those circles that are transparent. I hope I'm using the correct term, but you see things like these are outliers. Yeah, these are outliers. We have all these outliers. Yeah. So this is before we apply Winsorization. After applying Winsorization, this is what you end up with. So for example, let's take this one. Height versus MOAC. You see, there were a lot of outliers here, but now there are very few left. Take this one, for example, MOAC versus West. Very few now. Yeah, you can hardly see outliers, but here there were a lot of them before. So that's what winsorization does. It changes the values. One question might be, okay, what do you do with all the ones that remain as outliers after winsorization? Those you have to suppress now. But you see, the suppression that you do is much less after winsorization. So you're still keeping observations, but they no longer have the value that they had originally. They are now changed into something else to bring them together with the crowds. So that's information loss. But if you use winsorization, it's less. The loss is more limited because now instead of getting rid of, for example, if we look at height versus MUAC, I could have gotten rid of many observations, but now I'll get rid of perhaps I'm seeing, I don't know, 3, 4, 5. So you get rid of less values. I hope that's clear. So that's how we handled the continuous variables. And then this is what we did to the categorical variables. We had 5-year age groups. We recorded them into 10-year individuals, intervals. We had 20 categories. We ended up with 7. Marital status, we grouped together divorced, separated, and widowed. Already, already some researchers will raise eyebrows to say, no, divorce is different from separated and so on. But you're doing this to make sure that your data is less disclosive. And then education, this is what we did. Okay, so that's recording. And then this is what I was saying about suppression of some of the values. You have to prioritize, because if you remove the sex, then the utility of the data, for most purposes will be greatly diminished. So you want to look at some variables that you think you can deal with, more suppression of those. In our case, it was occupation and education level. This doesn't mean that they are not important, but they're less important compared to age and sex, for example. So in SDC micro, you can tell it to say, my priority for suppression of values, or for removing some of the data, remove more from occupation and education and so on. When you really can't remove more from these, then maybe consider the other ones. So in our case, we found out that we got acceptable levels of risk after suppressing, marital status, education, and occupation like this. You see, even marital status, we did not suppress as much, but occupation suffered a lot of loss. You might be doing a survey that's different. So maybe occupation is really important to you. Maybe marital status is not as important to you. Then that way you can change the prioritization for deciding on suppressions. This is the post-randomization method I was talking about. What it does is it changes the variables a little bit. These are the descriptions of the variables. So these things, we thought that if we were to suppress all these, then the information loss was going to be huge. So we opted for the method of altering some of the data. It tells you how many were altered for each of the variables. So again, you are not, your data won't be the same, but at least you have some usable data that you can potentially share widely. So we said that after you apply some anonymization, you have to assess what the risk is. So when we assessed, we found that at the end of the day, this was after many iterations. I'm just showing you the final result. We found that the expected number of re-identifications was 318, which we thought was acceptable for us. And the every combination of our indirect identifiers that we identified, there were at least 10 lines with exactly the same combination. So we thought that was sufficient for us. In some cases, I've seen some instances where they want 100. So they want 100 anonymity. So it all depends on the context. Okay. So then we looked at the utility of the data. My colleague, a data scientist within the project, then looked at some analysis, performed some analysis on the anonymized data to see whether they were still getting plausible results after the anonymization. Okay. This is the data set that we ended up with. So it got deposited at the repository at the London School of Hygiene and Tropical Medicine. Okay, so that's the example that I had. And then just to, I don't know whether we want to do this before question and answer, but this example that I've shown you is cross-sectional data. What we found out as we were looking at STC micro, I think it's more tailored for cross-sectional data. You need to think a little bit more how to apply it if you are using, if your data are longitudinal data. So I would like to highlight some work that we did together with colleagues at at Zurich University to see what's required if it's a longitudinal data set, so that you can sufficiently anonymize if it's longitudinal data set. So this is we did this work and published in this paper. Have a look if this is something of interest to you. See what we suggest there, and then see whether it will help you if you're working with longitudinal data. Okay, that was a lot of talking from me. I think that's all I had on data pseudo-anonymization and anonymization. So Diana, maybe we can go to the questions.
Okay, thank you. I don't know whether you're tackled. I have two questions on Q&A.
Okay.
Would have been so simple if you could do it in practical way. I think that's a comment.
Right. Yeah. Yes.
Yeah,
I agree. Could have been much better if we had to open the STC micro and shown you data being assessed and then being anonymized. But the International Household Survey Network have all the R code that does data anonymization. So links will be shared to that. And it explains step by step. There's a lot of information there in terms of how this could be done. So I do agree. A practical one could have been much maybe easier to understand. Yes.
Okay. There's Florence's Shalda, I don't know whether that's the spelling. More about wenzization. I don't know how to pronounce that.
Yes.
And which software you use to remove those outliers?
I used STC micro. So that whole case study that I showed was based on STC micro. It's an R package. So I guess it's a good opportunity if you're not an R user. If you're an R user, yeah. Yeah, that's also what I was saying, that it's actually not accessible at the moment, but it's a fairly stable and reliable package that has been widely used globally, not only in our case. So I'm sure it will be back on the R library of packages soon. But yeah, STC micro, yes.
Okay. There's Priska who has raised their hand, so you can unmute and ask your question.
Okay.
Hello. I would like to ask, to request that you share the study that was done by the University of Glasgow in Malawi, if you don't mind, kindly.
I'm not too sure. Are you asking for the data or the name of the study?
I'm asking for the study itself.
Okay, just there are some publications that came out of the study that you can look at if you're interested in NCD, the results that came from the study. And this data, if you're interested in the data, you can request them from the London School of Hygiene and Tropical Medicine platform called Data Campus. So I'll share these slides with the details. The publications that came from the NCD study, I can share links with the organizers to share with the team.
Okay, thank you.
Hope that answers your question.
Yes, yes.
Okay, we have another question from Balachu. You can unmute and ask your question. Hello? Okay. While you're waiting for him, I think maybe he has a technical issue. There's somebody who is asking, kindly share the package so that you can install and learn. Somebody is asking.
It's STC Micro. I'll just type the name, but STC Micro. But as I said, they have at the moment removed it. I've put it in the chat. They've removed it. They removed it from our the package of the library of our packages. But if you're an R user, it's still there in the archives, so you can access it there and play around with it. There's a lot of documentation on the International Household Survey Network, IHSN. They have a lot of guidance on how to do data anonymization in the way that I've just described. That's how I started using it, and then eventually ended up collaborating with people who developed STC Micro to do this work that I was just talking about now. But the guidance is detailed enough for someone to get started doing this. There's another question. Do you know its alternative in Python? No, I'm not aware of an alternative in Python, but a lot of people are working in this space, so it might be worthwhile. See if something of interest to you, might be worthwhile checking what might be available on the internet. So you can say statistical disclosure control using Python, and if you search that way, and then see what comes up.
Okay, thank you. There is a question from Balachu. You can ask your question. Balachu Hunde. Okay. Kyoko Dunda. Kyoko, are you there? Kyoko, your hand is raised. Okay.
It was by mistake.
Oh, okay, fine. Okay, let me see. From Q&A, someone is asking, is it possible to quickly run through analysis of the data collected?
Is it possible to run through analysis of the data collected? I don't quite get what they are asking about. That's analyzing to see what? To get like prevalences or things like that, or to do some, relating some variables to see whether there's any association between variables and so on. Is that what they're asking about? Is
I'm
it
not
possible
sure.
to
Let
quickly
me.
run through? Yeah. I'm not too sure what the question is aiming at, because our focus in this session is not looking at, okay, what were the results? What are the findings from this data? We are looking at how do we preserve, privacy of individuals in the data.
Okay. Okay, fine. Edwin, I think I've unmuted you, so if at all maybe you want to ask a follow-up question, please, you can raise your hands. Then you see. Okay.
Yeah, he said interpretation and association between
Okay.
variables.
Mm.
So this data can be requested for, and then yeah, you can analyze. So this SDC micro is an R package. So we know already that R has, capabilities for analyzing the data. So if it's useful in your context to perform some analysis on the data while you are looking at while you're trying to anonymize the data, then you could do that in R, I think. Yeah. Okay.
Okay.
What is the importance? There's a question from Idosa. I hope I'm saying their name correctly. What is the importance of data winsorization than directly removing the outliers? So winsorization is not removing the outliers. It's changing extreme values to bring them together with the other values. So at the end of the day, let's say someone is 2.5 meters tall in a population where the next tallest person is maybe 1.87 meters. So this 1.87 meters person is probably closer to the rest of the other heights. But this 2.5 meters person is an outlier. So that makes them very easy to identify. So winsorization would use some statistical methods to change their height so that it's closer to the other values. So you're not removing that outlier, you are changing its value. So you're altering the data. You're not removing that value. You're changing it. Yes, it is information loss because at the end of the day, the height that we're going to have for that person is not what we started with, but kind of keeps the data available. So that's part of the loss that you make while you are anonymizing data. So it is winsorization, I guess, is important in that it preserves more of the data. Directly removing, then you are losing more data. With the winsorization, you're losing in the sense of changing the value, but at least that person will have a value. I hope that answers your question. What entry-level role may you have for the newbies in research and trials, please? I don't know whether this question is in the context of statistical disclosure control or it's just a broad question. I'm not too sure. Maybe Charles can clarify.
Okay. While we wait for him to clarify, Belachu, are you able to ask your question now? You can unmute. I've seen. Okay, there you go. We can't hear you. Okay, maybe you can type your question on the Q&A. I have Priska. I don't know that it is an old hand.
I already asked my question, sorry.
Okay, let me know. From the Q&A, okay, I think we're done.
Yeah, I think so too.
Mm.
Okay.
There's from,
so over to you then, Dan, unless if there's another question.
Oh, there's one person who's asking, what entry level role may you have for the newbies in research and trial, please, in statistics?
So yeah, I'm not too sure how to link this to disclosure control. Yeah.
It's fine.
Yeah.
Okay, fine. Thank you so much, Shifundo. We've had quite engaging training. I know so many people have learned a lot from this session. Thank you so much for being engaging also, the audience. We really appreciate the fact that you joined. Okay, okay. I saw some people raising up their hand.
Right.
Okay, fine. Thank you so
There's,
much.
yeah. Yeah, I know, just people pointing out that, okay, this needed to be more practical. Yeah, I take that. I mean, we can improve on it in the future. Thank you for that feedback. Yeah.
Okay, fine. Before I invite the panelists to give out their final remarks, do you have your final remarks, Dr. Shipund?
No, just to say thank you for coming. It was a pleasure talking through this. We'll make the slides available, make the reference materials available, and